Hello, welcome, welcome, welcome. I am not John Oliver, but I am George Gould. I run Partner Alliances Business Development for Azul, and I'm going to spend the next 35 minutes today talking about Java certifications for ISVs and what ISVs need to navigate the new Java runtime landscape. Certainly, as we've seen for the last several years, there's been a real proliferation of different JDKs on the market. And ISVs need to make decisions on what JDKs to certify, recommend, even embed in their software offering. And today we're going to spend about 35 minutes going through a process that I think will help ISVs make the right decisions. But before we do that, Stefan, do you want to quickly explain to the audience some of the housekeeping rules?
Yes, absolutely. So this webinar will be recorded, and we'll send you a link to the recording sometime during the next few days. And that email will also contain a link to the slide deck that George will be going through during his presentation. There will also be questions at the end of the webinar presentation. There will be time for that. So please submit your questions via the question menu option in the control panel, and as I said, we'll address them at the end of the webinar. That's it, George.
Perfect, thank you. So the agenda today is fairly straightforward. I want to spend a little time on the OpenJDK project, a little bit of the histories, the realities of the project. I think this will be an important level set for folks on the phone. Then we're going to talk a little bit about a methodology, a way of simplifying the Java certification process. And really the goal of that is to identify what I call a reference implementation. And from the reference implementation, a way of creating a process where you might certify a single or many different OpenJDK and proprietary JDK vendors. The way we're going to accomplish that is by looking at an evaluation framework, a way of creating a checklist so that ISVs can understand the requirements, not just their requirements, but also their customers' requirements when choosing a JDK as that reference implementation. And then ultimately to support that effort of once identifying the needs through this ISV checklist is coming up with an approach, a scorecard, that you can apply the JDKs to understand which ones might be better suited as a reference implementation. And then I want to open it up to Q&A. As Stefan said, if there are any questions that you have on any of the slides over the course of the presentation, put them into the chat and we will address them at the end. And there should be sufficient time to cover those. But before we dive in, I think it's also important to understand that I've been at Azul now for almost 11 years, and there's a number of different questions that I get from ISVs of all shapes and sizes. Everything from small vendors focusing on SMB and embedded market all the way up to strategic partners that I manage like Microsoft. And there are a number of questions that I think are going to be important for us to look at for this presentation to address. And we will try to address most of these, and we'll come back to some of these questions to ensure that the presentation has covered them appropriately. The first question that I get a lot is how can potential differences between Oracle and OpenJDK-based runtimes impact my Java certification process? And are those differences limited to specific versions of Java, such as Java 8, Java 11, in the near future, maybe Java 17. And this is very important. We certainly know that back in 2019, many ISVs were simply certifying Oracle, and it was the right choice because it was freely available. That, of course, has changed with the new Oracle licensing models. OpenJDK is a very important open source choice that many ISVs are providing their customers. And it's important to understand that there are some subtle differences, and we're going to look at those so that ISVs understand some of the risks or specific areas of testing they need to look at. The next question is, what criteria should I use to evaluate different OpenJDK-based distributions? And will certification of one distribution provide coverage for others? So as I mentioned, there truly is a very large proliferation of different OpenJDK distributions. Literally, two guys and a dog can build an OpenJDK-based runtime, very different than what you might see from larger dedicated vendors that are focused exclusively on the Java market. So we're going to look at these, and really the major emphasis of this presentation is to allow ISVs to come up with an approach to carefully examine, understand requirements, and then apply those to come up with a reference implementation for certification. Now, I also got a number of questions on how can I ensure that if I distribute or redistribute an OpenJDK-based Java runtime with my application, that it's not going to force me to open source my code. It's not going to impact my intellectual property. And this is important because many ISVs have decided to not only certify a JDK, but also embed that. It provides a great out-of-the-box experience for their customers, but there are implications that you need to carefully consider when embedding a Java runtime. And we'll talk about this when we get into a little bit of the licensing of the OpenJDK project and things you need to consider. And lastly, for people, again, ISVs that intend to embed or redistribute, what obligations do I have when I redistribute? Particularly because the predominant license of OpenJDK is GPL v2. So those are common questions I get. There's going to be others that we can, again, people on this webinar can type in and we'll review at the end. So let's jump into a little bit of the history of the OpenJDK project. As many people know, OpenJDK is the reference implementation for Java SE. It has been since Java 7, circa 2011. It is a fairly complex project. Remember that it's over 7.5, almost 8 million lines of code. It's got 20 years of history, so there's some legacy here. And it has a number of different third-party licenses associated with that code, about 50, and they include very benign licensing all the way to things like GPL v2, which is a contaminating license. There's also what is called GPL v2 with class path exception. This is a very important distinction from the GPL. GPL is contaminating, but the class path exception, when these tags and notations are appropriately associated with the source codes of OpenJDK, it doesn't force contamination. So very important subtle differences, and there are many other third-party licenses that can affect an OpenJDK distribution. Another important thing to point out, when Sun initially open sourced Hotspot back in 2006 with Java, in 2006 with the release of Java 6, there were some closed source libraries, things like the font rendering engine, that had to be substituted from what was in Hotspot at that time with what was going to be in the OpenJDK source code base because of the licensing associated with those third-party components. The good news is the core runtime between the Hotspot contribution and what was in OpenJDK is truly identical. And if we actually look at the Sun Oracle distributions in those days to what is in an OpenJDK distribution such as Azul Zulu, the Oracle distribution on the left, you'll see when you look at the center underneath the Java SE specification, you'll see that the core Java virtual machine, the Java APIs that we know and love and use in our applications are common and are part of the specification. However, as you look out a little to the sides of the Java SE specification, there were some subtle changes that were needed to be made as Sun and Oracle open source the core code. And these subtle differences are with libraries predominantly in headful implementations along the lines of font rendering engines, color matching, 2D rendering. In the case of the Sun Oracle distribution, which is a proprietary distribution, they were using products like T2K versus on the right, the OpenJDK community went with FreeType. And you saw changes also with color matching, where the Kodak CMS was replaced by Little CMS. And the rendering engine on the left is Ductus, where it was Pisces for Java 6 and 7, and Merlin, work that Azul and the community did to backport that 2D engine from Java 11. And there's some subtle changes also outside of the core Java SE specification. These are additional libraries that Oracle and Sun included in their distribution, but are actually not part of the Java SE specification, which means that the contribution by Sun and Oracle and other third-party vendors have changed a little bit. And different distributions, OpenJDK distributions, may or may not have these additional components. But if we look at Azul and what they've been doing with Zulu, you'll see that there are many core equivalents. So Java FX is available in both distributions. Mission Control and Flight Recorder were actually backported from Java 11 by Azul and made available to both now the community as well as a part of the Azul Zulu distribution. And there are a couple of others related to things like font libraries and Java scripting engines. The key takeaway here, getting back to a question that we saw on the prior slide, which is, as an ISV looking to certify and maybe has traditionally certified with an Oracle distribution, as they start to look at OpenJDK and wanting to certify an OpenJDK distribution, are there subtle differences that they should focus on in their initial testing to ensure that they can transition, that they can support their application with an OpenJDK-based distribution, whether that's from Azul or another vendor? And the simple answer is yes. But if you are a graphic-focused application, maybe you're in the medical space and you have image rendering is a key part of what you do, there's probably some additional testing that you should do that would focus around font rendering, color matching, 2D, where there are clearly two different libraries. It doesn't mean you'll get different results, but these are different libraries. The good news is many ISVs over the last 3, 4, even 5 years have been transitioning or simultaneously testing Oracle and OpenJDK together. And many problems that were identified many years ago have now been addressed, both in the OpenJDK community as well as vendors doing work to address those. So any differences that have been found over time have likely been addressed. But I would advocate that if you have a rendering focused application, a headful application, there are some areas of testing to ensure compatibility. Now, a footnote at the bottom there is very important. While there were changes and differences, more of them pronounced in Java 6 and 7, fewer in Java 8, the good news is Oracle has closed the gap with Java 11. There are no differences. So all the libraries that have been in OpenJDK, like FreeType and Little CMS, are now the standard distribution. So that is very important, because as vendors look at certifying, and they may be certifying on Java 11, Java 8, and Java 7, there are going to be subtle differences. But as we go forward, the next long-term release, which will come out in about 2 years of Java 17, again, no differences between these two packages or distributions. The other good news with the OpenJDK project is, since Java 7, all development is done truly in the open. I often get questions about, does Oracle hold back any contributions? Are they doing special development in Java 15 right now that they're going to contribute in a couple of weeks that they only keep for their proprietary distribution and they don't make available to the community? And the answer is no. Oracle, the steward of Java, has done a very admirable job of doing all development in the open. In fact, Oracle engineers and the Java community work together in collaboration right now as they prepare for Java 15, which will be available in a couple of weeks. And I think that's a very important statement. But there's one caveat here, which is security vulnerabilities are not done in the open, and that would make sense. The last thing you would want is Oracle and the Java community working together on a serious security vulnerability, and black hats being able to look at the same code and see what vulnerabilities are being exposed without a binary that addresses that vulnerability. As such, there was a group formed, the OpenJDK Vulnerability Group, that includes a handful of vendors, folks like Oracle, IBM, Red Hat, and Azul, and others sit on this community, sit on this active group, specifically addressing the vulnerabilities in Java, working together, collaborating. You would have seen in the last release that there are collaborations that Azul even contributed a major security vulnerability fix in the last release. But we did not release that independently. As part of our work in this group, we're all embargoed to release security vulnerabilities at the same time. So no single vendor has an advantage. And the last thing any vendor in the Java community would want to do is, again, expose a security vulnerability that the other players, the other vendors wouldn't have in time to be able to apply to their distributions. So a very good group and a working group that has, again, been able to address security vulnerabilities and done it in a coordinated way so no one is left out. And I think that's, again, a very important statement about where OpenJDK project is today. Again, OpenJDK is the common source code base across all Java SE vendors. Now, that doesn't mean that people's distributions aren't different. There are subtle differences that we'll talk about. There are ways of curating, there's ways of building and management and quality and QA and backporting that can create subtle differences across these different vendors. But it's important to understand all the vendors, including Oracle, are playing from the same source code base. And as I mentioned on the prior diagram, since Java 11, all of those distributions are playing truly from an identical source code base. And I think that's very important again. Now, there is an important difference here between when we talk about the licensing of OpenJDK and the 50 different licenses that govern it, to a very important process or a very important subtlety around once a vendor builds a version of OpenJDK, what additional steps are needed to ensure that that binary distribution meets the Java SE specification, and more importantly, inherit the intellectual property rights, the IP rights of all the different vendors and contributors to the OpenJDK community, which not only includes intellectual property from Sun and Oracle, but also from IBM and Azul and Red Hat and many others, vendors that have contributed intellectual property to the project over the course of the last 20 years. And the rules of those contribution was that a compatible and compliant implementation of Java would inherit those IP rights if and only if that binary distribution met the requirements of the Java SE specification. And what is a subtle difference here in OpenJDK is while the code, OpenJDK sources, are truly open source, they're based on GPL v2, you can go build a binary today without any special licensing from Oracle. However, the OpenJDK technology compatibility kits, the TCKs, are not open source today, and they're only available through licensing by Oracle. So while the code is open source, to ensure that what you are building as a Java vendor has to be certified by these TCKs, and the TCKs are granted actually by each version of Java. So there's a TCK for Java 6, for 7, for 8, and then for 9+. And there are many OpenJDK vendors that actually don't have access to TCKs for all versions of Java. And we're going to talk about that as an ISV that may have needs to certify in multiple versions of Java. And when you look at vendors, it's going to be important to understand, do they have the TCK, the compatibility kits for all versions of Java that you're interested in? Because if you don't have assurance that the binary that you're trying to use not only passes, but has guaranteed to pass the TCK compatibility kits. And these are, for Java 8, about 110,000 unit tests that you need to run on your binary as a Java vendor. And the outcome is a pass, no pass. If it passes, it means you've met all the requirements of the Java SE specification, and you inherit the intellectual property rights that allow you to run and use that distribution. If it doesn't pass, quite honestly, that is a walking liability. It allows any patent holder to potentially bring litigation against the user of that binary. So TCK compatibility and passing is a critical component. It's also a very important quality step. As a Java vendor, you want to know that the way you built 8 million lines of Java code has met the Java SE standard. So it is both a quality standard and a very important IP transfer component. And we'll talk about this later when we're evaluating distributions. Now, a final footnote here, and there's often been confusion in the market today. OpenJDK is an Oracle trademark. It's also an Oracle product name. As such, no other vendor can call their distribution OpenJDK. So often, when you hear vendors that build OpenJDK-based distributions, they'll often give it a name: Adoptium, Corretto, Ice-T, Zulu. These are names that the vendors give their OpenJDK-based distributions because they can't legally call it OpenJDK. Now, there's some subtleties of the OpenJDK, of the Oracle trademark and branding. For example, you're allowed to use the word OpenJDK as a noun. Azul Zulu is a certified build of OpenJDK. You can't say it is OpenJDK, but you can say it's a certified build. Or an ISV can post support of a TCK compliant Java 1.8 OpenJDK based distribution. That is an appropriate way to talk about an OpenJDK based distribution. So subtle differences, it's important to remember, because there are a lot of distributions out there on the internet today. And if you see a vendor that is an Oracle calling their distribution OpenJDK, be cautious. They probably don't even understand the legalities and the trademark associated with this brand. And that's going to be, I think, an important indication of the seriousness of that vendor. So let's jump into a certification process, a methodology that I think I have found working with ISVs on their Java strategies that is going to be helpful. And the first step here, we're going to talk about this many times throughout the presentation, is choosing a reference implementation. Yes, there are many distributions out there today. Many of them are adequate. Some are better built and quality than others. And it's going to be important that as an ISV looking to minimize the amount of time to test different distributions is to pick a reference implementation through a comprehensive evaluation framework that we're going to cover in the remainder of the presentation that combines both the vendor and product criteria to identify a vendor distribution that meets the need of your product team and the customers you sell to. And that last piece is critical. It's important as an ISV not to get myopic and only think about certifying a JDK that meets your needs, because ultimately that JDK is consumed by your customers. And they have requirements too, and we're going to talk about those. The second piece is depending on the certification goals and scope, multiple distributions may still be needed. And this is, there really is no shortcut when it comes to certification process. While you may pick a reference implementation for an OpenJDK product, you still might find yourself, because of your need to support Oracle, maybe it's early versions of Oracle like 6 and 7, those subtle differences require you to continue to test both. This methodology doesn't say that real work isn't needed, but a reference implementation can really help mitigate the proliferation of other Java, open source Java runtimes that you may need to certify. So maybe you can get this down to 2 certifications rather than 4, 5, or 6. The next step is be prepared to certify your application on a quarterly basis. Now I know firsthand, I was a GM at BEA Systems for many years, had very large product teams. Back in 2006, 7, and 8, we had very complex certification process. At that time, there were 6 or 7 different, distinctively different JDKs, and you had to go and test all of them. We know this is a time-consuming process. This could take anything from a few days to a week. But the reality is Java is not a static release. In an individual release on a quarterly basis, there can be hundreds of bug fixes, tens of security updates, and enhancements. That means that you can't simply test a version of, let's say, Java 8 and assume that the next version that comes out, you can avoid testing. Part of this recommendation today is that you focus on those quarterly releases and provide at least some testing as part of your standard process. Now, you might find that a release comes out, it has very few security fixes in it, it might have a minor number of bug fixes, and you can do essentially a smoke test just to make sure that the out-of-the-box experience is sufficient. But be prepared is the key takeaway here. There are no shortcuts when it comes to ongoing certification with Java. And then the final step is, again, getting back to the needs of the customer. Offer the right set of Java certifications. Think about casting a big net when providing an open source choice of your runtimes, so that an ISV can meet the diverse needs of your product team and the customer. Recognize today, customers have needs that can span multiple versions of Java, operating system subtlety. So it's not just Linux, it could be many versions of Linux. And it's important, does that vendor support and test across those different versions of operating systems? It could also be the importance of having native installers to simplify that installation. It could be that it's important as an ISV that is selling support for your Java stack, that the Java component, the JDK that you're going to recommend also has optional support available to it. I've seen many ISVs pick and recommend a distribution, a JDK, that in fact has no commercial support behind it, which can create an awkward situation when they're recommending, when the ISV is recommending their customers to get support, but they can't get support for the critical component of the JDK itself. So we'll look at some of these criteria and how they relate. So a 3-step process here: pick a reference implementation, be prepared to certify, and think about all the choices that are going to be needed that would affect the Java certification. So a goal that I often ask ISVs to aspire to is, again, think about casting a big net. Don't just think about, when you even pick a reference implementation, that's the only version of Java you're going to support. Ideally, you would like to come up with a broad statement, such as a TCK compliant Java 1.8 OpenJDK distribution for x86 Windows, Linux, and Mac. With a statement like that, if you pick the right reference implementation and do the right set of certifications, taking the right approach, you can be fairly broad in your approach. And I think that's a key approach here that you can take. So before we talk about how we do analysis and how to find the right reference implementation, let me talk quickly about the word curation. I'm going to use it in several places in this presentation, and I think it's important that you understand the definition of curation and, more importantly, how it applies to Java vendors. So curation, the act and process of selecting, organizing, and looking after items in a collection or an exhibit. Now, many of you might know the word as it relates to maybe an art exhibit. San Francisco MoMA is putting on a well-curated exhibit of Andy Warhol, and it's done through a curator that has had 17 years of experience in the industry, and they know how to come up with the right components of an exhibit to talk about his life work. Well, how is that relevant to the Java or a Java vendor? Well, let's use curation in an example here. Azul's curation of their Zulu OpenJDK-based distribution is based on 17 years of experience-based knowledge as a Java provider and designed to reduce out-of-the-box friction. And so this is a very important word here. OpenJDK is a very good open source project, but there's careful attention that needs to apply to ensure that what you build and ultimately what components are in your distribution are providing a very high quality, consistent, and frictionless runtime experience for your customers. And the work that you need to do as a Java vendor to go above and beyond simply building the OpenJDK code and the experience that you can apply to that. And we're going to talk about that in a little detail. So let's talk about a Java valuation framework. This is vendor criteria plus product criteria, what I call the 6 truths for evaluating Java runtimes. There are 3 criteria I'm going to talk about here as it relates to a vendor, and then 3 related to products. So the first is curation, understanding a distribution's pedigree. When you talk about things like dogs and understanding their pedigree and their history, it's very important. It's important to what I call avoid the mystery meat of JDKs. There are JDKs out on the internet. There are Docker images that contain JDKs where the origin of those JDKs are unknown. And those unknown JDKs carry associated IP and licensing risk, as we talked about. So it's very important that as an ISV looking to identify a reference implementation to base their Java certification on, that you spend some time understanding the vendor's build certification, their curation process, as we talked about. Are there TCKs available? Do the vendors have TCKs for all the versions of Java you need? Do they guarantee that every version of the JDK they make publicly available has guaranteed to pass the TCKs and therefore have the IP indemnification? Does the vendor stand behind their work? For ISVs that want to embed, there are very important licensing verification process that some vendors go through and others don't to ensure that the APIs that the ISVs use or that the customers might leverage through their applications on top of the ISV's framework, are they clean? Do they contain the GPL v2 with class path exception tags? Are there other licensing ambiguities in the code that needs to be cleansed to ensure that there's no API that could contaminate the ISV's codes or the customer's code? And then there are quality issues. What rigor does the Java vendor apply to ensure that they're building OpenJDK correctly? And the last one here is the completeness of the backport. Oracle and the community fix lots of bugs today in the Java 14, the Java 15 code bases. But how well does the community and that particular vendor backport the different fixes that Oracle has contributed to the latest versions of Java? There are many examples over the last 3 or 4 quarterly releases where the community lagged fixes that Oracle had fixed, made available in their binaries, but the OpenJDK community took more than 90 days to apply them to the OpenJDK code. So very important to understand the capabilities of the vendor that you're choosing and the ability for them to keep pace with the fixes that are being contributed to Java 15 or Java 14, but needed to be backported to the versions of Java you use. The other thing to look at a vendor is alignment. Look behind the curtain. Who is really behind a project that is building OpenJDK? Successful projects to date usually have an aligned commercial vendor behind them. So when you look at this distribution, does it come from a Linux operating system vendor that's focused on Linux, but does provide an OpenJDK distribution? Does that Linux vendor have your best interest in mind when they're curating their distribution, when they're building and testing? Do they have sufficient tests on all the operating systems that you care about? Are those tier 1 tests and tier 1 platforms? What's the vendor's capabilities, as we talked about, to backport those changes from Java 15 to 14? Does the vendor have a sizable or a critical mass Java team to actually accomplish that? Or is that vendor dependent on what other people do in the Java source codes, and they simply build from the source code but don't contribute? So is your vendor of choice a real set of human beings doing active work, or are they just a farm of build bots that are dependent on other people in the Java community to ensure that changes are backported on a timely basis? And the final piece here is the track record. What's your vendor's history in ensuring that when Oracle contributes the changes to Java 14 and soon 15, that they make those binaries, those new quarterly binaries, available on a timely basis? So when Oracle comes out with a new release in Java 15 in a couple of weeks, and in October, the 3rd week, there'll be an update to LTS releases. How soon after Oracle makes those binaries available can you get access to the new changes? And this is critical. Remember, your customers, your enterprise customers using your software, when a new Java version comes out and that new Java version contains a number of important security vulnerabilities, and maybe they're high scoring. We saw last quarter, security vulnerabilities was a 9+. So CVE, critical vulnerabilities, are scored from 1 to 10. When you see a new security vulnerability that is in the order of 9+, enterprises often need to deploy those within 48 hours. But if your vendor of choice hasn't even built and made a binary and tested and certified it, that could be a problem. You now have a situation your customers are running into problems with that release, regressions that were introduced in the latest release before you even have a chance to certify it yourself. So look at track records and understand the cadence and history that they've done. How do they make new binaries available? Do they only make them available as PSUs, patch set updates that contain bug fixes, security updates, and enhancements? Or are there variations of those binaries that are for security only, that allows you to rapidly test your ISV software and ensure that it meets and addresses all the security vulnerabilities? Now let's look at a little bit of criteria as it pertains to a vendor's product. We talked about this, operating systems. Does it have the depth and breadth? Is the product available from both a Windows, Linux, Mac, and different performances? Are they all tier 1 platforms that are all made available at the same time? So you might see the distribution available on a Linux platform within a week of the distribution, but you don't have the equivalent binaries on Windows for a later time. So understand all of the operating systems, and are they tier 1 platforms with the same level of testing and schedule? Security patches, we talked about understanding the different binary packages. Curation, we've talked about this as well. It's one thing to build an OpenJDK distribution. It's another to ensure that it's curated to make sure that the out-of-the-box experience is truly compatible with the Oracle distributions historically and contain things like Java FX libraries or Java Flight Recorder or font libraries to ensure that level of compatibility. Also, what is the availability for optional commercial support services? Again, we've talked about the importance of your customers being able to get support should they need it. Also understand that vendors need, there needs to be a good archiving for older versions of Java, and that you as an ISV need to look at whether those older versions are still actively supported. So as you move forward, providing new releases, you also need to ensure that the vendor is supporting the prior older versions of Java, and they are well curated and archived. And then there are also subtleties around versions of Java that are still relevant in the enterprise today. We still see many of our enterprise customers running on Java 7, yet there are only 2 vendors left that are supporting Java today. So again, when you start to look at the depth and breadth and the requirements of products, look carefully at what the vendors are offering. Another important concept to look at when you look at products is product life cycles. It's very important today that as an ISV, if you're going to pick a vendor in a particular distribution, that the product life cycles for those JDKs, for those Java runtimes, meet the needs of your products and align with your product life cycles. And if you're an IDE, if you're a DevOps ISV, you want to encourage your Java developers to stay on the cutting edge of Java. Maybe they're using Java 13, maybe 15. Maybe they need and want to look at early access binaries. Does your vendor of choice, does your reference implementation allow your customers to use or explore early versions of Java through EA, or what I call non-LTS availability? And then lastly, optional support services. This is very important today in the community as more government regulation, as larger enterprises require that every component in the runtime stack have support contracts. It's very important that as an ISV, you're choosing, you're supporting, you're recommending a JDK that gives the customer the option to get support for that runtime, for that customer to get an out-of-cycle patch should there be a regression in Java, and ensures that that customer can get the enterprise class support services they need and guaranteed access to updates. So a very important component when looking at a product. It's not just availability, it's not just does the binary have the product lifecycle, but is there optional support services that meet the needs of your customers all the way up to truly mission critical 24/7. So we've laid out a framework now for both evaluating the vendor and evaluating the product. If we look at all those options and we put it together, an ISV now can come up with a list of what I call the ISV checklists. Now, not every vendor is going to look at these and say, oh, I don't really need a native OS installer, and 32 bits not going to be relevant for me. I can uncheck that box. But the vast majority of vendors today are going to check these 19 or 20 different options here and come up with a list. And it's important, again, don't think about just your needs as a product team, but also the needs of your customer, as we've talked about. And you might have many of these checked. So now you have to take your checklist and apply that in a meaningful way to the different distributions that are out there today. And to do that, you need to come up with an approach, what I call a JDK scorecard. You need to apply the criteria that we've talked about, a way of critically looking at a vendor, and a critical way of looking at a vendor's distribution and applying a rating system to those distributions. This example of a scorecard is using a rating system from 0 to 4, and it's actually expressed in a visible way, actually called through a font called Harvey Balls, where if you see a red empty circle, that's a 0, and a 1 is a black box that's filled by a quarter, a 2 is a halfway filled box, a 3/4 is a 3, and what you want to look at are the boxes that have a completely closed black circle. That indicates a 4, the highest score. So when we look at the criteria from the prior slides, we then apply them on a scorecard that looks like this. You can go through this criteria. So the criteria on the left, I've started with a section around IP, intellectual property, and licensing considerations. These are the questions around, is this truly an open source and freely available distribution with no field of use restrictions? Are there TCK testing guarantees? Is there guaranteed patent grants and indemnification that comes with those TCKs? And you can see the scores from other OpenJDK distributions as well as Oracle in the fourth column, and how well these different vendors are doing addressing the specific criteria here. As you move to the second tier around the vendor and the products yourself, you'll see scores related to a vendor's track record. The ability to provide quarterly updates in security only or critical patch update only distributions. And you'll see today that only Azul, with their Zulu distribution in Oracle, makes a security only binary. And this is very important for ISVs that want to quickly test and recommend to their customers a binary that allows them to quickly deploy, because that binary only contains the security changes from the prior release. The other piece here is what is the availability of those binaries? Are they available on a download site, or are they available through automated repos that allow for more systematic integration through commands like yum or apt-get? And that's very important too, because we want the ISV customers to have quick and easy access to new and updated binaries. And then the last section here is product offering. This gets back to, again, everything from product life cycles to the availability of the binaries on different platforms, including Solaris, which is still a very relevant platform in the enterprise today, but also things like Java FX. And people might say, why is Java FX, a graphic library, relevant to an OpenJDK distribution? And the reality is there are many third-party products, even ones being consumed by ISVs today, that historically, 5-10 years ago, a Java developer decided to use a library, a class in Java FX that was not about graphics, but it was about a capability that existed in Java FX. And because that library was available and freely available at the time in a Sun or Oracle distribution, that became the way of using Java FX. And we have found that many applications out there today do rely on classes that are available only in the Java FX library. Hence, we provide Java FX libraries in our distributions, and you might find that you are consuming third-party components that do also rely on these. So again, careful attention to the curation of the vendor's distribution. And then the last piece is the support that we've talked about. What level of support is available, how fast, and what are the service level guarantees to ensure that your customers can get the level of support they need. So when you look at this score, if this was an example, you would add up a score and you would be able to identify quite easily what is your reference implementation for open source Java. And from that score now, you would be able to pick a distribution that would give you all the qualities and abilities that you would need to say, I can certify this as my reference implementation for Java. I know I have fast access. I know I have the right sets of distributions. I have it on the platforms I need. It comes with the IP and indemnification I and the customers require, and it comes with optional support. Your scoring could vary depending on how you could weight some of these. Hence, I don't have a particular number here because some people might weigh some of these. ISVs could weigh these slightly differently. But it is important that you do the homework to ensure that your reference implementation is supportive of the needs of your product teams and customers. So with that, I'm going to quickly end a final slide here as we open it up to Q&A. Going back to our original 4 questions, I think number one, we've talked about the differences and how there were subtle differences in early versions of Java 6, 7, and 8, where there are no differences now between Oracle and OpenJDK and 11 and beyond. And I think that's important as you look at what testing is and isn't required. So you can truly feel confident that a single version of Java, your reference implementation for Java 11, can cast a broad enough net that if you certify a single well-curated version of Java 11, that you'll have confidence that it can come close to supporting all the other distributions. What criteria should we use? We just talked about it. I think that's the key emphasis and takeaway of this presentation, that if you follow what was outlined here today, that you will have confidence that your reference implementation will provide a broadcast, a broad net to cover what comes out on a quarterly basis, allow you to stay ahead of your customers, and give you confidence that your support statements, your public support statements, can be more and more generic and provide a larger set of OpenJDK-based distributions as part of your certification efforts. How can I ensure the distributions don't contaminate? And again, this comes back to understand your vendor's criteria and understand what work and diligence do they have around testing of the TCKs for their distributions. The last one here was still an open question, which is what obligations do I have redistributing? GPL v2 based distributions have very set rules and requirements. Section 3 of the legal languages actually has a very spelled out set of definitions of what requirements you have, such as the ability to offer source code for your JDKs that you embed. You have to keep those for 3 years. You have to make a formal offer. I don't want to get into it here. I don't want to play lawyer, but I do recommend that for folks that are embedding and redistributing an OpenJDK distribution, you carefully read the obligations here and understand those, because you cannot leave it up to your JDK distributor to make sure they are doing everything correctly. So on that note, Stefan, why don't we open it up to questions with the remaining time we have?
Yeah, and as Lee mentioned earlier, any questions you have, you can submit via the question menu option in the control panel. And so let's just give it a few seconds to see if any questions come up.
Perfect. As we wait for those, also the slide deck that will go out, I've added some links to additional materials that should be helpful. There is a similar JDK comparison table on our website for people that want to dive deeper. We have published our product life cycles for the Azul distributions. There's information about security-only binaries versus patch set. And at the bottom here, you'll also see a link to the legalese around GPL v2. So for people and ISVs that are interested in embedding, understand and read it. It's not complicated, but there are important obligations that you carry by redistributing. That's going to be important that you meet, so you don't get a cease and desist letter and you have to remove the embedded runtime. So Stefan, I'm going to turn it over to you to see if there's any questions. I know there was a lot of material here. My contact information, I believe, is part of, I will make available in this, so you can certainly follow up with me offline.
Yeah, you've done a very thorough job because I cannot see any questions at this point. So
perfect. Well, thank you. And again, any questions, you can reach out to me individually. Thanks everyone for attending, and good luck with your certification process.